Hello everyone. Previously we had discussed on the topic this one, searching algorithms, right? So we were done with the exponential search. Today we'll be continuing with this one, linked list algorithm. First we'll be starting with this one, Floyd's cycle detection algorithm, right? So let's get into the definition part. So what the definition part say here? Floyd cycle detection algorithm is a pointer algorithm. So basically it is used to detect the cycles in the linked list, right? So this algorithm we make use of it to solve many problems. We have already solved many many problems using this algorithms and this one while solving the LeetCode problems or the this one Codeforces problems, right? So basically this is the this algorithm is a pointer algorithm used to detect the cycles in the linked list, right? It uses two pointers basically, a slow pointer and a fast pointers, right, which move at the different speeds to find if a loop exists, right? Again, it uses two pointers, one is slow pointer and another one is fast pointer, which move at different speeds to find if a loop exists. So let's get into the definition part. Let's see the first point. Let's try to understand this one and let's try to implement the same thing in the form of code, or let's try to articulate the same thing in the form of code. So first what we'll do, we'll start with the two pointers, slow and fast, both at the head of the linked list, right? So this is fine, I believe. The slow pointer moves one step at a time, right? We'll start with the two pointers. As I've said, one pointer will be slow and another pointer will be fast, both at the head of the linked list. Initially both pointers are kept at the head of the linked list, right? So the slow pointers moves one step at a time while the fast pointer moves two step at a time. So this is simple. Slow pointer will move one step ahead and the fast pointer moves two steps ahead, right? So if there is no cycle, the fast pointer will eventually reach none, right? So if there is no cycle, then the fast pointer will eventually reach none. If there is a cycle, then the fast pointer will eventually move the meet the slow pointer inside the loop. So these 2 points are important. If there is no cycle detected, then the fast pointer will eventually reach none, right? So if there is a cycle, the fast pointer will eventually meet the slow pointer inside the loop. So this is very important, these 2 points, right? So this method works on time complexity would be big of n and the space complexity would be big of 1, right? So let's try to articulate the same thing in the form of code, right? So this is fine, man. First let's define the simple node class. So I'll just go with class. So this one node def. So this one let's move on with the initialization part here. So this one will be init self. This is fine, man. This is, let me go with a value, right? So this is fine. The next step would be, let's store the node's value. Also initially next will be none. First we need to store the node's value somewhere, right? So I'll just go with self dot val. So this one val is fine, and self dot next, so this one will be none. This is fine as well, right? So this is fine. So the next step would be, let's create the linked list with a cycle. So I'll just initialize head to node of let me give 1 here. So let me copy the same thing here some more time. So I'll just give here some 5 times is enough. Yeah, 5 times is enough. Let me go with head dot next. So this one will be head dot next dot next. So this is fine. And the fourth one will be head dot this one next dot this one will be next as well. Next dot next, one more next here. So this is fine. And finally 4 times next. Let me go with here next dot next. We have to go with one more next, right? So this is fine. So node value differs here. First we have given 1, second we'll be going with a 2 3 4 5, right? So this one will be node 1, this one will be 2. So let me give 3 here, let me give 4, and finally let me give 5 here. This is fine. 1 2 3 4 5. This is fine, man. Now let's create the cycle, meaning we have to point the last node to the second node, right? So last node in the sense this one. Let me copy the same thing here. We are just creating the cycle by making use of the last and the second node. Let's point the last node to the second node. Second node consists of the head dot next, right? The second one. So let me type this. This is fine, man. Now let's do one thing. Let's implement the Floyd's algorithm, right? So this one I'll just go with def. Let me name the function has cycle here. So let me pass the parameter head. I need the parameter head initially because we have to keep the slow and the fast pointers both initially at the head itself, right? So this is fine, I believe. First, let's initialize slow to head and also fast to head. So this one will be fast to head as well, right? So next, let's move on with the while loop. We have to loop while fast and fast dot next are not none, right? So I'll just consider while fast and fast dot next. This is fine, right? So while fast and fast dot next, let's initialize slow to slow dot next. So this one will be slow dot next. This is fine. Fast to this one, fast dot next dot next. This is fine, man. So we are moving fast by 2 steps, right? So this is fine, right? So this is fine. So if they meet, then cycle exists, meaning if slow this one equals fast, then this is fine. So we have to return true. Yep, we have to return true. This is fine, man. Finally, what we'll do, let me return false. So I'll just return here false. This is fine. If fast reached none, then there is no cycle, right? So if fast reached none, then there is no cycle, right? So then we have to return false. So this is fine. Let's move on with the final step. Nothing but let's go with the example usage, or let's call the function and print the result. So I'll just give here result. Let me assign this one to the has underscore cycle. This is the function name that we had written at the beginning. So let me pass the parameter head here. This is fine. And let's print something for the interactive purpose here. So I'll just go with cycle. This one, if the cycle is detected, let's go with the cycle detected within the strings. Also, let me pass, let's do one thing. Instead, I'll go with a question mark here, right? So this is fine. Let me pass the result as well, result variable, right? So we need to print what we're doing, we need to print let's print the boolean value. If the cycle is detected, then let's print the value true, and if the cycle is not detected, then we have to print the value false, right? So this is fine, I believe, right? Yep, this is fine. Now let's do one thing. We are done with the code. Let me explain this one very quickly, and then let's run the code, right? So what we have done here, basically we have created a node class, this one, line number 17 to 20. So we have created a node class just to build the linked list nodes with a value and next. So that's what we have done here till this one, right? Till the line number 28, starting from the 17 to 28. Next, we are creating the 5 nodes 1 to 5. See, the same thing, node 1, node 2, node 3, node 4, node 5. We are creating the 5 nodes, and then we are linking the last node 5 back to the node 2, forming a cycle. Basically, we are linking this one, line number 28. We are linking the last node 5 back to the node 2, forming a cycle. Let's move on with the step 3. So in has cycle, this one function, so 2 pointers slow and fast start from the head. Basically, see here we have this one, initialize slow to head and fast to head as well. If slow equals fast, if the value of the slow is fast, then they meet inside a loop, right? Then the cycle will be detected. Basically, if fast or fast that next becomes none, then list is ended, no cycle is formed, right? So that's the core idea, right? That's what we have written within the while loop and the if while loop within the if condition, right? So this is fine. Then we are calling the has cycle of head and printing true or false. This one, this is the example usage. Basically, in our case, the cycle is detected because we have assigned the last node 5 back to the second node here, which forms a cycle, basically, right? So let's try to run the same thing. We have to get the this one, cycle detected question mark along with the boolean value result we have to get true, basically here, right? So let me copy this one. Let me give Control J Just give me a second. Yeah, let me give Python here, file name dot py. So see here, cycle detected. Yeah, we are getting true, meaning cycle is detected because we are considering the last this one. What do we call last node? We are pointing this one to the second node, which forms a cycle basically. Head dot 4 times next to the head dot next basically, which forms a cycle. So we are getting the desired output basically. So what we are doing here, the print statement outputs true here, this one whatever we made use of here, this one with here in the line number 44, the print statement outputs true because the fast pointer caught up to the slow pointer inside the loop created between the nodes 2, 3, 4 and 5. Right, so this is fine, man. So this is it for the Floyd cycle detection algorithm. So this is the simple algorithm. This is also known as this one, tortoise and hare algorithm, right? So usually we have, initially we start with this problem itself. Whenever we start the linked list, usually I have started with this algorithm itself. Whenever I hear the name linked list, so I basically hear the word tortoise and hare algorithm or the Floyd cycle detection algorithm, right? So usually when we start the linked list, we start with the algorithm Floyd cycle detection algorithm or reversing the linked list, these two things, right? So these two things we have to know at any cost, right? So this is it for the Floyd cycle detection algorithm or the tortoise and hare algorithm, right? So we are done with this algo. Let me summarize whatever we have learned so far. Just try to remember this one along with the algorithm. So the first point here would be Floyd cycle detection algorithm. Basically what it does, it efficiently finds the cycles using 2 pointers. One thing, the time complexity and the space complexity we have already discussed. The time complexity would lead to big O of n and the space complexity would lead to big O of 1. And one more thing, if slow equals fast, right? So at any point, then the cycle exists. If the fast reaches none, then no cycle exists, right? So this is the main point, as we had discussed this one earlier as well. Just keep these things in the mind, right? So we are done with the Floyd's cycle detection algorithm. So next we'll be discussing on the topic merge to sorted linked list tomorrow. So that algorithm is also very important. Reversing a linked list, merges a sorted this one linked list, and detecting and the detection and removing the loop, that is also one of the important algorithm. Cloning the linked list with a random pointers, these are very important algorithms. So tomorrow we'll be discussing merge to sorted linked list. For now, this is it. Thanks for watching, guys.